6.2, Solving Systems Using Substitution. The learning target, to solve systems of equations using substitution. Math terms. Substitution method. A method of solving a system of equations by replacing one variable with an equivalent expression containing the other variable. Yesterday we solved systems of equations using a method of graphing. Today we're going to learn the method of using substitution. Our goal is the same. We're looking to find an ordered pair, an x and a y, that would be the solution for both of these equations. You notice in step 1, I wrote since y equals 3x. That's the first equation. It told us that that's what y equals 3x. Substitute 3x in for y in the equation x plus y equals negative 32. So we're going to take our x plus y equals negative 32. That was the equation that we're going to replace y with y equals 3x. Okay, because y equals 3x, so I can put that in for y. So I have x plus 3x equals negative 32. Step 2 tells you to solve for x. Since there is only one variable, we can solve this equation. X plus 3x is 4x, which equals negative 32. And then we simplify by dividing both sides by 4. X equals negative 8. We found our value for x. So now step 4 tells us substitute x in either equation to find y. So I can use any of the two equations that are listed above. Doesn't matter which one. And I'm going to plug in negative 8 for x. So I'm going to use the shorter one. Y equals 3 times negative 8. And we find that y equals negative 24. We now have our solution, which is the ordered pair, negative 8, negative 24. We're going to check our answer by substituting, which is the same way we did it yesterday. We're going to plug it back into both equations. So we have y equals 3x, and we have x plus y equals negative 32. Y is negative 24, and x is negative 8. So negative 24 does equal negative 24. So it checks. Now let's check the other one. X equals negative 8. Y equals negative 24. Added together, they do equal negative 32. So both sides also check. Now's a chance for you to try it. You can go back and rewatch the last example, or you can just follow what you have written down and try to do this yourself. In this problem, you can take y equals 2x plus 7. Okay, you would just take the 2x plus 7 and plug it in for y. So this one's a little bit different, so I'm at least going to help you get started. So I'm going to take this and plug it in for y. So your equation would be 2x plus 7 equals x minus 1. Now you'll want to continue, solve for x, and then go and find y. So finish trying this on your own. Solve for a variable and using substitution. If you look at these two equations, neither one of them says y equals. So we would have to make them y equals in order to use the substitution method. So when you look at the equations, if there is an equation, which is not always the case, but if there is, that only has a coefficient of 1 in front of the y, that's the one you want to use. Because then you don't have to do any dividing at the end. We're going to take this equation and we're going to make it y equals. So I have negative 2x plus y equals negative 3. And since y is what I want to get by itself, I have to add 2x to both sides. And I get y equals 2x minus 3. Now I have y equals, which tells me that y equals the value of 2x minus 3. So I'm going to take the 2x minus 3 and put it in for y in the other equation. Now I know this can start to get confusing. Just try and follow through with me, and we will be practicing a lot of this tomorrow. But keep in mind y equals 2x minus 3. That's what y equals, so that I put that in place of y. So when I do that, I have 3 times that, because that's the value for y, plus 4x equals 14. Now we have to do the distributive property before we can solve this equation. So we have to distribute the 3. 3 times 2x is 6x, and 3 times negative 3 is negative 9. We can combine like terms on the same side of the equal sign. So we have 10x minus 9 equals 14. We'll add 9 to the other side. (10x) equals 23. Divide by 10. X equals 2.3 or 2 3/10. Now that we solve for x, we have to take our answer for x and plug it into one of the equations for y. Now the only thing I would recommend is not to use the one that you made when you solved for y. Don't use this one. If you want to use that equation, use it in its original form. In case you made a mistake there, and the x value would work there, but not in the original. So I would go back and use the original form. Again, you can use either equation, but make sure you use the original form of it. So now let's take our 2.3 and we're going to plug it in for x. So I have negative 2 times 2.3 plus y equals negative 3. Now I know we're not always crazy about having to have decimals and fractions, but this actually is a pretty simple one. Negative 2 times 2.3 is negative 4.6 plus y equals negative 3. So we're going to add 4.6 to both sides, and y equals 1.6. Now we just have to perform our checks to make sure it works. So here's our original equation for the first one. 3y plus 4x equals 14. 3 times 1.6 plus 4 times 2.3, and we have to make sure that that all will equal to 14. So 3 times 1.6 is 4.8 plus 4 times 2.3 is 9.2, and that does equal 14, so that side checks. Now we have to check the other equation. Negative 2 times 2.3 plus 1.6 has to equal negative 3. Negative 2 times 2.3 is negative 4.6 plus 1.6 does equal negative 3. So that also checks. So I know that my answers are correct. Okay, here's another try it for you. Again, you can rewind the video, go back and follow those steps, use the ones you just wrote, or just try it on your own. I'm not going to get you started on this one. I want you to try and do it by yourself. Solving systems with infinitely many solutions or no solutions. We go about the same process when solving these. It's just the answers will tell us if there's infinitely many solutions or no solutions. So let's start with our first equation. X equals negative 2y plus 4. This is what x equals. So we're going to take that and we're going to plug it in for x. Now we haven't done that yet, but it's okay to do that. It doesn't have to be y equals, as long as we know what one of them equals. So now we're going to rewrite, and we have 3.5 times negative 2y plus 4 plus 7y equals 14. So in this case, we're going to solve for y instead of x. 3.5 times negative 2 is negative 7y plus 3.5 times 4 is 14. And then we have plus 7y equals 14. Now when we combine like terms on the same side of the equal sign, we have negative 7y plus 7y, and they cancel out. We get 14 equals 14. Now this should sound somewhat familiar. We've done this before. Since they do equal 14, this means there are infinitely many solutions. Okay, because we found it to be true. And I also want to remind you, when you're looking for infinitely many solutions or no solutions, the variables cancel each other out. So you're looking at those final two numbers. Do they equal each other or not? Okay, let's try this example. The first equation tells us what y equals, so we'll take that and plug it in for y. So we have 3x minus 11 minus 3x equals negative 13. Again, you could see here that the variables cancel out, but our final answer says negative 11 equals negative 13. Since that is not true, this is no solution. Okay? Make sure you finish the try-its, have all the notes complete, and we will work on this again tomorrow in class. Have a good night.